Okay, so the first thing we're going to do is to visualize this mesh that we have here. So we start out with the mesh, we visualize it, and then we compute the boundary sets, or get to the boundary sets. So let's create a new cell here, and then we can actually just run this code like this. So we have nodes and we have P now, and don't bother with these guys. So let's see here, nodes and P. All right, so the thing is that once you have your mesh generator as a function like this, and you can input all of your parameters here to get your mesh out like this. The first thing you want to do is visualize it to confirm that it's working. So let's see what we can do here to visualize this. We're going to use the patch function for this. So patch, and use this method. So we provide the faces, those are the nodes, and then we say that the vertices are P, and then we need a face color here. So face color is W. If we don't provide face color, it will default black, and W is face color of white. Okay, so in order to, yeah, you can just run this, or you can create a figure as well, like this. So we can run this, and see here that there is no setting face of class patch, value must be handle. So faces is the right one, and there we go. Okay, so we have this thing here now. The axes are off, so we need to fix that. So let me just bring this, dock this into this window here, and also let's do axis equal, and I just press F5 and it actually goes out again. It won't stick here. So yeah, so axis equal is going to make this thing equal here. We could also do tight. Yeah, so do axis equal and tight, and if you run this, the tight command will actually change the axis limits and will bring this as tight as possible around this mesh. Okay, so this is the first step. The next one is we want to draw the node numbers, all the node numbers for this whole thing. And how can we do this? We can do this with the function text. So that's text here. And if you press F1, you can see the syntax for text. So it takes an argument x, y, and then text. And if you expand this, let's see here, x is a coordinate and y is a coordinate, and text is, well, just a text value or this thing. So there are a couple of options of doing this. So let's see here, we can do text, and then we have the coordinates. They are in P. So the x coordinates are P1 and the y coordinates are P2. And what about this now? Well, we want to have the node numbering from 1 to the number of the size of P. So let's create a new variable called number of nodes. So n nodes is equal to, and then we can do size P, and then the first dimension that will give us the rows. Okay, so if we evaluate this, we get 306. All right. The thing is, okay, let's continue here. Now we can do just nodes 1 to 306 here, number of nodes. This will give us a vector like this. And yeah, so we have this vector now, and we want to throw this vector in here. But this is not a string. That's the problem. We need to convert this to a string. Okay, so there's a function called string to num. Sorry, the other way around. Num to string that does this. The problem is if we evaluate this thing now, this string, this will not work the way we want it to work. So we have to do cell string. It's called cell str, and then we put this whole thing inside of there. Okay, and when we evaluate this, we get this thing. So it's a cell of containing these guys. But see here, there's a problem now. This has to be transposed so that actually this transpose should be in here. If we reevaluate this, yeah, now it's alright. There was a problem with this. Yeah, so this is a cell array now containing texts. These are strings, and then they're containing these values here, the numbers. Okay, and you know this is needed in order for text to process this without creating a loop. Okay, so if we just run this now, we'll see that we have a bunch of text now at these positions here. Okay, you can press the middle mouse button to pan around in Xfigure. Okay, so it's kind of hard to read, so you can add another thing to this. We can add the parameter background color. You can set this to, for instance, white. If you rerun this, then I need to actually zoom in here. You can see what's happening. All right, cool. So let me just change the size of my mesh here. I can set it to 10 here, so that it's quadratic, and then the size, the element size, I can increase it to 5 maybe. Rerun this, and this is what I get, which is fine. So save this. So now you can see here that it's much easier to read. So I have the node numbers here in white now. All right, so this is cool. The next thing I want to do now, once I have this, is to create the element numbers. Another way of doing this is by looping over the elements. So let's do this. So we're gonna loop over all the elements. So I will call the element variable IEL, and then this is going to loop from 1 to the number of elements, which is size nodes 1, and then I need to close this with end here, and then I have IEL here. Okay, so if I just run this now, I have my elements 1, 2, 3, 4. Okay, so size nodes. I can also create a new variable here called number of elements and just put it in here, and then I can reference number of elements in here. Alright, run this, I get the same results. Okay, so what I want to do now is I want to find the nodes for this element. So the first one will be 1, 4, 5, 2. So how should I do this? Well, nodes are containing all of these. So I'm gonna do nodes. I'm gonna say I want the first element, the first row of this element, and then all columns. And if I press F5, I can see that I get these 1, 4, 5, 2, 1, 4, 5, 2, and then 2, 5, 6, 3. Let's see here, 2, 5, 6, 3. So this is the second element. All right. So what can I do with these? Well, I can create the coordinate, maybe let's say the x coordinates. Let's call them IXC is equal to P, and let me actually save this to something. I usually call it IV for the local nodes, but yeah, let's call it what it is, the local nodes, lock nodes. Okay, so I'm gonna grab these now and put them in here. So I want to select all of these nodes, and then for the first dimension, so that's the x. Okay, and copy and paste this down here. I'll also do it for the second and call this y now. Alright, so I'm gonna create a breakpoint here. I'm gonna run this. So it stopped here. So I can just hover over this now for IEL1. The local nodes are 1, 4, 5, 2, and the x coordinates are 0, 5, 5, 0. And that makes sense, right? You have 0 here, the next one is 5, and then the one after that is 5, and then this is 0 as well. Okay, so I can step through here and look at the y coordinates. Alright, so what I can do with these now is I can take the mean value. So I do mean IXC here. If I do this and I evaluate this, I will get the value 2.5. So it took the mean value out of this vector here, which is 2.5. And I can save this into a new variable called MXC, mean x coordinates. Okay, and if I copy this down here, change the name to y, I grab the y component of this. I now have, if I evaluate this now, I have these two guys. Alright, so this is my coordinate for the mean. Alright, so now what I'm gonna do is I'm gonna copy this text here, throw it in here. Okay, so the coordinate, the x coordinate is gonna be this, and then the y coordinate is this. And now I get rid of this cell string. Okay, and I'm going to do number to string. Make sure I type that right. And then what is the number of this element? Well, it's IEL. It's 1. I throw this in here, and now I'm going to change the background color to something else. Let's go with cyan, so C. Okay, so I'm gonna now if I go to save, see the break. I'm quitting the debugging. I'm gonna remove this breakpoint here. And I'm gonna run this. And what do you say? So the sign boxes here containing the element numbers 1, 2, 3, 4. So if I now decrease the element size here to, let's say, 3, if I run this, I get this thing. Alright, so it works, it's scaling. Cool. So I'm gonna change this back to 5. Alright, so now and this is really good for debugging or for developing really.